Okay, here are the solutions to your midterm review for confidence intervals and hypothesis test. The first one, why need to construct a confidence interval for the mean amount of air that a balloon holds. They gave you 18 balloons, so you have to find the sample mean. Now you can put those in list 1 and then calculate the 1-bar stats. And you should get 19.35 for the sample mean. The Z star value that goes with a 95% confidence interval is 1.96. And then sigma, they told you in the problem, was 0.92. And then the square root of 18 is because the 18 sample size. I just want to point out that 0.92, I do believe in the 1-bar stats that something is 0.92, but you got to be careful that when you do the 1-bar stats, it does give you a sigma and S value. But when the problem says that sigma is 0.92, then go with that no matter what, because your calculator doesn't know that it was just a sample of 18 that you used. Okay, so make sure that you understand that 0.92 is coming from sigma being 0.92 that they tell you in the problem. Okay, so when you do your confidence interval, it's fairly straightforward. You guys did pretty well on it on the homework assignment. So you find the margin of error to be rather small, 1.425, and then here's your 95% confidence interval. Okay, so we're 95% confident that the mean amount of air in the balloons is between 18.925 cubic centimeters and 19.775 cubic centimeters. Now, as far as rounding goes, just round to whatever I tell you to. If I don't tell you what to round to, then the general guideline is to round one more than what you're given. So if they gave you 0.92 as your standard deviation, and your mean is 19.35, then just go one more place than that. That's not something I go too crazy about. It's trying to catch you on rounding errors. Okay, and then in part B, they want you to test a claim that the mean air held in a balloon is on average is more than 18.8 cubic centimeters. So you set up your hypotheses, you calculate your test statistic, which is 2.536, and then with an alpha of 0.05 on a right tail test, that gives you the critical number of 1.645. And your test statistic of 2.536 is more extreme than that. So that means we reject HO. So there's enough evidence to support the claim that the mean is greater than 18.8 cubic centimeters. Now I just want to point out the other way you can do this, rather than comparing the test statistic, 2.536, to the critical number, 1.645, rather than do that, comparing those two, you can compare the p-value and alpha. The p-value is the probability of getting a sample mean as extreme as this. Okay, as extreme as 19.35 if the mean really was 18.8. So that 2.536, if you look up 2.54 in the Z table, 2.54 gives you 9945. Well, that's the area to the left of 2.54. So the area to the right is 1 minus this, which is 0.0055. So that's the p-value here. So you can compare that p-value to alpha, and p is less than alpha. Okay, so 0.0055 is less than 0.05. So that means you reject HO and you support the alternative. Part C was just testing the claim that the mean is different than 19.7 cubic centimeters. So again, if you calculate the test statistic for that, you get negative 1.61. Now in this case, with the two-tailed test, because mu does not equal 19.7 in the alternative, so that means you're a two-tailed test. So divide the alpha, which was 0.01, divide that by 2 to get 0.005, and that gives you your critical numbers of plus or minus 2.576, or 2.575, depending on the table that you're using. Okay, so if you compare your test statistic to that critical number, your test statistic, negative 1.61, is not too extreme. So it's closer to 0 than your critical number. So we failed to reject HO, which means there's not enough evidence to support the alternative, which was the claim. So not enough evidence to support the claim that the mean is different from 19.7 cubic centimeters. Okay, then number 2, this had to do with women's high school basketball scores. Again, construct the confidence interval. Okay, not much for me to say there. On this one, the confidence level gave you a z-star value 2.576 or 2.575. And then your confidence interval is 14.6 to 49.4. And then for the testing a claim that the mean number of points in women's high school games is less than 50. To test that claim, again, we find our test statistic, negative 3.68. We had a one-tailed test because mu is less than 50, means we're on the left-hand side, so less than. And alpha was 0.05, so the z-star value that goes with that is negative 1.645. And if you don't know where those values are coming from, go back to my videos for that module and watch those videos. So in this case, your test statistic, again, is more extreme than we were willing to go. So we reject HO. And that means we have enough evidence to support the claim that the mean number of points is less than 50 points per game in women's high school basketball. Then number 3, on this one, we were given alpha is 0.01. Our test statistic, I think, was 2.15. I can't remember exactly what I put on the paper. But whatever it was less than 2.33, which is the critical number that goes with alpha equals 0.01. So in this case, this is kind of like the one up here, the two-tailed one up here. We failed to reject HO because we did not go further than our cutoff point of 2.33. Okay, we're not more extreme than the critical number. So we failed to reject HO. We cannot say anything about the claim because we don't know what the claim was. All we have was the decision to reject HO. They didn't tell us whether the claim was HO or HA. Okay, so that is the review for the confidence intervals on hypothesis tests.